Solana processes 130 million transactions daily, but during network congestion, up to 75% of transactions failed. That's 500 million failed transactions annually, and costing over 150 million in wasted priority fees. I analyzed transaction data to find out the root cause, and I found three critical failure nodes. 18% comes from block hash expiration. If your transaction doesn't land within that window, it's rejected with block hash not found. Around 20% comes from RP's infrastructure issues like rate limiting, geographic censorship, and provided downtime, single point of failure architecture, and the rest comes from slippage. So, but these failures are solvable with the right architecture. And here comes Belay, and it has four reliability layers. Layer 1 is multi RPC routing, real time health monitoring across Helios Triton Quick Node, which recovers up to 60% of RPC failures. Automatic retry with fresh block hash is layer 2 that detects expiry errors, then fetches new block hash, then resigns, and then with exponential backoff, it recovers up to 80% of timing failures in 4.8 seconds average. Layer 3 is about machine learning computation unit prediction. So we have a random forest model that is trained on 400 transactions with real-time monitoring, which predicts optimal CU with 82.5% accuracy that prevents exceeded compute budget errors. And layer 4 is priority fee optimization. There is percentile based as of now, plus congestion adjustment, which saves up to 30 to 14% of maintain high landing rate. So here you can see there are three transaction scenarios. This is from Jupiter, from Iridium, and that is on a complex swap. So let's see Jupiter how the simulation works in the SDK. So when you run the ML analysis, so based on the network instruction and parameters and the availability of the RPCs, it tells that the congestion is 2%, and on that the ML predicts with 400 real transactions that the confidence of the transaction is 80%. And based on these two scenarios, the smart fee optimization optimizes the parameters based on that, and then the user decides to send it. Let's consider another scenario where there's complex swap and we run the ML analysis on that, and you can see that the network is kind of changing is 11%, and based on the complex swap instructions, the ML is likely predicting 95% failure, and based on the ML here, the smart fee optimization increases the compute units by 20% and boosts the priority fee to 98th percentile, and then enables the multi RPC routing to make the transaction successful. Let's come to the tech stack. So here you can see on the GitHub we have a couple of modules open. One is a retry engine, RPC router, ML predictor, fee optimizer, and a couple of Python models where we have trained our random forest regressor and classifier. Everything is on GitHub. You can audit the retry logic, inspect the machine learning training data, and verify the RPC health checks. I am Nagavaishak and this is Belay, built for Colosseum Cyberpunk 2025.